Hey guys, it's Miss Johnson. I am going to talk to you about You Don't Need a Lot, the assignment you're going to do this afternoon. I'm going to give you some background, some equations you can use to do this assignment. We're going to go over a couple of examples of both type on the work, and then I'm going to let you loose. You're going to watch this video, you're going to do the assignment. If you have questions on the assignment, you're either going to email me or Schoology message me or come to my office hours from, let me write this down. My office hours today are from 1 p.m. to 2:50 p.m. on Mondays. All right, let us get to the math. Let me make this a pencil. Let me make this purple. The two pieces of background we want, the two kind of equations we're going to use, are called point slope form and slope equation. And in any math class, my advice to you is when you're given an equation or you're given a formula or you're given a, like a routine or a skill, you want to know two things. You want to know, what do I need to be able to use this equation? And why am I doing it, right? So for point slope form, we're going to use this when you have a point and a slope of a line, and we want the equation, right? And the big thing here is the point is not our starting point. It's a random point, right? So when we have a random point on the line, and when we have the slope, and when we want the equation, we're going to use point slope. Okay, let's name our stuff. We're going to call our slope M. Nice. We're going to call our point. Oh, my screen is messing up. Okay, it's fixed. We're going to call our point x1 and y1. You'll see mathematicians do this a lot because this is like point number 1, right? And then want to say this is the x coordinate of point 1. So we put this little sub 1 and the y coordinate of sub 1. But this is just kind of like 3, 7, 8, -3. This is just like any random point where we're calling these our x1s and we're calling these our y1s. If these, for example, were given as our points. Okay, so point slope form, I'm going to put this in a different color. Point slope form is we've got a y, and this will stay y in the end form of our equation, minus y sub 1, which in fact is a number, it's this number, is equal to m, the slope, so that's a number we're going to plug in, parentheses, multiply times parentheses x, that'll stay x, minus x sub 1, which again is a number we're going to plug into this line. All right, this is our equation. This is our, let me get purple. This is the point slope form of a line. I'm going to do a quick example so we can kind of see what the heck I mean when I say that. So if you are given that the point 317 is on a line and that your slope is, 5/3, we can plug this into our equation. Our equation, again, is y minus a number equals mx minus some other number. The number for y1 we're going to fill in is 17, because this is our y1 of our point that we're given. Our m is 5/3, so we're going to actually fill in 5/3 here. And then our x1 is 3, which means we're going to put a 3 here. That, I think, is a finished equation in point slope form. If we wanted to put it in y equals mx plus b form, which is what we've been doing, we would distribute the 5/3. See, there's a reason we did all this distribute stuff, right? That becomes 5/3 x minus 5 times 3 is 15. 15 divided by 3 is 5. And then we would add 17 to both sides to solve for y. And we would get our equation is 5/3 x plus 12. And this is how we got our equation, starting with a point and a slope, right? We used point slope form because we wanted the equation and we had a point and a slope. We'll get more practice with that down in the examples. For right now, I'm going to give you another equation. I'm going to move my face so we can see this equation. We're going to go over the slope equation. Again, we want to see when do we want to use this and what do we need to have in order to use this. All right, we need 2 points. They do not have to be the starting point. We're going to call the first point, just like we did in the other equation, x1 and y1. We're going to call the second point x2 and y2. And these are just names. These are just names. You can give your first point, the first coordinate is x1, the second coordinate is y1. Your second point, your first coordinate is x2, and your second coordinate is y2. It's just a way to name 2 points. And we want the slope, so we want m. Okay, here is the equation. M, the slope, is equal to the change in y. And the way we find the difference of things, the change between 2 numbers, is we subtract them. So we'll take the second y and minus the first y. That's the change in y. How far up and down we moved. And then we want the change in x, how far left and right we moved. And we'll do that again by subtracting the 2 x coordinates. It's very important that if you do the second y coordinate first in the numerator in the top, that we also do the second x coordinate first in the denominator in the bottom. All right, that's our equation. Let's do an example. If I have 2 points, and my points are, we'll say 317 and, I don't know, -1, 11, and I want the slope, I would say, okay, I have 2 points, I want the slope, it's time to use the slope equation. I would say the slope is equal to the second y minus the first y divided by the second x minus the first x. 11 minus 17 is -6. -1 minus 3 is -4. Oh no. When we do a negative divided by a negative, it turns out to be positive. And when we do 6 divided by 4, we get 3 halves. And this would have been our slope. All right. So that's the point slope form. That's the slope equation. These are great equations to know. We'll use these all the time in life and in math. So getting to your assignment. Here's kind of the 2 versions of the questions on your assignment. One, you're going to get a table that does not have the starting point filled in, and we're going to want to find the rate of change, the starting point, and the equation. And then there's going to be a couple questions in the bottom where you're either going to have the rate of change, the starting point, the equation, a non-starting point, or a second non-starting point, and I'm going to ask you to basically fill in the rest of these items. You're going to be given 2. And that's all you need. That's why the worksheet is called You Don't Need a Lot, because you only need 2 of these to be able to find all of them. Let's start with the table. If we wanted to use our new equation, which honestly we do, here, if you want the rate of change, you would say rate of change is slope, the second y minus the first y divided by the second x minus the first x gives us the slope. We get -3 over 2. Boom. We have, for the first question, found the rate of change. The starting point is when we say, okay, we went up 2 here. If we want to go down 2, we would get 2. If we want to go down 2 again, we'd get 0. And our starting point is when x equals 0. So this is what we're looking for. Here we went down 3. So here we'll go up 3 and then up 3 again. So we'd say the starting point is 16. Great. From these 2, we can write the equation. We've got mx plus b, where this is the m and this is the b. All right, let's do that again with some weirder numbers. We want the slope, we want the start, we want the equation. I'm going to use my new slope equation to find the slope. I do the second y minus the first y divided by the second x minus the first x. The bottom is easier to do, so I'm going to do 12. I'll grab my calculator and do 27 minus 101, which is negative 74. Negative 74 over 12, both of these can be divided by 2, so we'll get negative 37 over 6, and this is as simple as we can get that. And then you might say, oh my goodness, how are we supposed to fill in the table if the slope is negative 37 over 6? And we're supposed to jump by 1. That doesn't seem incredibly feasible. Good news, we've got this new equation, right? We've got this new point-slope equation where we have a point, right? We've got a point, we've got the slope, we want the equation. That's exactly when we use point-slope form. So we're doing good. We have two things. We know what we want. We're ready to go. Let me delete this. Let me just put it over here. Okay, so for point-slope equation, what we do is we remember that it's y minus y sub 1 equals mx minus x sub 1. So we've got y. Y sub 1 is 101. I've decided that this is my x sub 1 and this is my y sub 1. Equals negative 37 divided by 6 multiplied by x minus x sub 1, which here is 1 and negative 36, 7 over 6, right? Good. We're going to solve for y because that's what we usually have our equation looking like. We're going to do this by distributing first. We get negative 37 over 6x plus 37 over 6. And it's a plus because we've got a minus times a minus. A negative times a negative is a positive. Okay, we add 101 to both sides. This stays the same. And now we get 37 divided by 6 plus 101 is, I'm going to use a decimal, 107.167. And whenever you're doing calculations like this, feel free to use a calculator, right? I'm not trying to make our math be this long multiplication problem. So our final equation, even though it's gross looking, is basically this. And now, once we have the equation, boom, we've got the slope, boom, we can read off the start point from the equation. So getting the equation using point-slope form is kind of a fast way to get the starting point. All right, so that's that first part. I'm going to go ahead and scroll down now and do two of these examples, which is when we're given some of the information and we want to find the rest of it. Okay, if your starting point is 0, 4 and a different point is 2, 11, and I want to find the slope, I want to find the equation, and I want to find a second non-start point. Right, so these are my three wants. These are my two halves. Let's get to it. My slope equation is going to come in clutch here. I'm going to use my slope equation. I'm going to say my second y minus my first y divided by my second x minus my first x is how I get the slope. The bottom is easy to do. 2 minus 0 is 2. The top is 7. That seems right, which means our slope is 3.5. I'm going to go put in 3.5 for our slope. For our equation, I know it's going to be 3.5x plus something. Our something is 4. We don't have to do any more calculations because we already know our starting point. Oh, we actually are asking for our starting point as well. No, we had it, so we're good. We just get to plug in 4 because we know the starting point already. And then if you want to find a second point, what you're going to do, you're just going to pick any random x and plug it into this equation, right? Substitute it into this equation. So we would say y is equal to 3.5 times 4, because I picked 4 as my random x, plus 4. 3.5 times 4 is 14, plus 4 is 18. So another point on this line could be 418. It's not the only right answer for this one, because you could have picked any x, but that is another non-starting point, which would be on our table if we were filling a table. All right, second example. Your slope is 5 over 2, and a point on your line is 4, 8. So we're looking for the starting point. That doesn't even look right at all. Plus, I want it to be orange. Looking for the starting point. We are looking for the equation. We've got the rate of change. We've got this. We need the starting point. We need the equation. We've got a non-starting point. And then we want a second point that's not the starting point. Okay, so right now we've got a point and we've got the slope, and we look back up here and we say, okay, if we've got the point and the slope, right, we're going to use point slope form. Scrolling back down. Point slope form is y minus y sub 1. Our y sub 1 is just our y value of the point we were given, equals m times x minus x sub 1. All right, we're going to solve for y because we want the equation. We do that by distributing. Five times 4 is 20, divided by 2 is 10, which is why it's minus 10. And then I'm going to add 8 to both sides as well, to then simplify to 5 over 2x minus 2 being our equation. Okay, we can read off that negative 2 is our start point. Right? From our equation, we're always able to just look in the back and see what our start point was. If we wanted to put this as a coordinate, we would say x equals 0, y is negative 2 at the start. And then our second point, again, we're just going to plug in a random point here. I'm going to plug in 2. So 5 halves times 2 minus 2. The 2's cancel. We just get y is 3 because it's 5 minus 2. And there's our second point. All right, guys, again, y'all, sorry. If you are confused, if you are struggling, come to office hours. Email me. Reach out to your group. Reach out to your older siblings. Like, make sure to get help. Don't sit at home confused and stressed about math. Reach out, and we will get through this together. Thanks, guys.